the next thing we're going to talk about is the Delta Force cylinder. So this is the hydraulic cylinder we're using to manage both our downforce and our lift as well. There's a lot of variance across the bar to where we feel like managing the downforce is one of the biggest benefits a grower can get to the row unit itself for emergence. We take about 200 readings a second with Delta Force, and we control to 1/5 of a second. It is being read over here. There's a load cell on the back side that gets ran through here, and that's how we know how much gauge wheel weight we have. So when the gauge wheel weights come up, it will read through this load cell here. As we go farther down the row unit, we're looking at the VSET meter. Now this is the mini hopper version for this particular row unit, along with the VSET 2 meter made by Precision Planting, which is compatible for both a seed tube and a speed tube. We got it also paired with the V-Drive motor. So this is our variable rate, row by row controlled. It's our auto swath controlled, row by row, as well as turn compensation. So we'll adjust our population according to a curve or a waterway or around power poles or whatever it may be. It'll speed up and slow down each individual row to hit that population. With this particular meter, we can plant numerous amounts of crops, but like I said, we'll plant corn, soybeans, and wheat with it, all by just changing one disc. So it's very friendly as far as switching from one crop to the next. Underneath it here, we got speed tube. We did run the speed tube, so we are planting what we call a high-speed planter by Precision Planting. Here it's our electric drive motor, just like what we have for our V-Drive, as well as the feeder wheels. So basically these feeder wheels pull the seed off of the disc, put them in these belt flightings, and the belt actually pushes the seed all the way down to the bottom of the furrow. Therefore, as we speed up to 7, 8, 9, 10, 11 mile an hour, we don't have to overcome gravity by the seed free flowing through the seed tube. It's a very simple design, works very effectively. We got a sensor on both of these eyes to know if we got a skip or a multiple. It'll allow us to know that. As we can tell here, here's a sensor here, and then here's a sensor there. Works very sleek, very easy. And then a grower can just pop this down, open that up, and look to see inside of his belt. But the feeder wheels will turn, and then so will the belt itself. So you can kind of see how that action works there.